Welcome back everybody, I hope you're all safe and well. Today we're going to be taking another look at Mitsubishi PLC programming with GxWorks 2. However, today we're going to be having a look at one of the best features inside of a PLC, and that there is how to create a function block. We've actually worked with function blocks on this channel before. We've used them inside a Siemens TIA portal, inside a Siemens Step 7, as well as Mitsubishi GxWorks 2 last week. Function blocks are blocks of code that can be used as many times as we want inside of the program, and we can address different forms of inputs and outputs to the PLC. So if you think about a timer or a counter inside of TIA portal, that there is a function block. Siemens has created that block using code within inside of the PLC, placed it inside of the function block, and then they allow us to use it as many times as we want to create a timer operation. We can then tweak things here and there with different forms of inputs, different forms of outputs, but the fundamentals of the program remain the same inside of the PLC function block. So what we're going to do is we're going to have a go at creating our own function blocks, and we're going to do it today using GxWorks 2. So what I'm going to do is I'm going to flip you over the laptop and then get started. Okay, so at the moment we've got our Mitsubishi GxWorks 2 PLC programmer open up at the moment. What I'm going to do here is I'm just going to go to project and I'm just going to go to new. And it's going to ask us again, just like we did last week, what sort of series of PLC do we want to use? We want to use the FX CPU, and we're going to be using the FX2NC. That's the one that's connected to me behind me. And then the type of project that we're going to use is a structured project. We're not going to use a simple project here. Because we want to create function blocks that is a part of the REC standard, that there will be needing our structured project format. Our language is going to remain as structured ladder and FBD, function block diagrams. Just say OK to that. And again, our POU1 will open up, ready for us to write a program. So today, we're just going to take a simple approach of creating a function block just to show you the very basics of how to understand how a function block works. And what we're going to do is we're going to create our StartStop Latch that we've been creating in a lot of our videos before. However, this time, instead of us creating the StartStop Latch inside of our POU, we're going to create that StartStop Latch inside of a function block. And then what we can then do is use that as many times as we want. If you aren't aware of how a StartStop Latch is created, we create one like so. We select our normally open contact, add that to our network, select our normally closed contact, add that to our network, add in our output coil after that, grab another normally open contact and place that below our first normally open contact, and then connect that to our top rail here. We then want to give this addressing. Now, I'm not going to create any global labels just yet. I'm just going to tie this straight to the X's and Y's. So X0, X1, Y0, and Y0. So the way this works is when X0 closes, which is going to be our start push button, X1 will remain closed because our stop push button hasn't been activated. Y0 will then turn on, and it'll then turn on this contact here, allowing us to latch on Y0. We can then let go of X0, which will then open this contact, but Y0 will remain on. We can then reset Y0 by using the X1 contact, pressing the stop push button in. That then opens that contact, disabling our latch, allowing us to start it again. So that there is effectively our start-stop latch. Now, if I needed to design another 10 start-stop latches, what I would then have to do is I would then have to create 9 new networks and then create that start-stop latch another 9 times. Now with a start-stop latch, you've only got 2 normally open contacts, a normally closed contact, and a coil, so it's not too much work to do that. But imagine a program where we have several networks as part of one operation. If I then had to design the operation several more times, I would then have to take those networks, duplicate them, change all of the addressing to then represent the new hardware, and then do it again, and then again, and then again. And that there is where it can become very time consuming. You can also make mistakes very easily, because you might then miss a contact that needed to be addressed, and that then is a bug inside of your program. What a function block allows us to do is it allows us to take this code here and place it inside of a function block. And that's what we're going to do now. So to create a function block, on the left hand side underneath POU1 is FB and FUN, and FB and FUN stand for function block and function. We're not going to have a look at functions just yet, we're just going to have a look at function blocks. To create a function block, right click the folder and then select add new data. When we select this, the first thing that pops up is function block. Now we can drop this down and choose another type of block, but we're going to leave it as a function block. And then it's going to ask you for a name, and I'm going to call this StartStop Latch. Next, it's going to ask you what sort of programming language are you wanting to use. Well, I'm going to use structured ladder and FBD. I'm not going to look at structured text, I'm not going to look at an instruction list. I'm just going to be using structured ladder. And then all we want to do is then select OK. And this then creates our function block. And if you look at the function block, it looks very similar to our POU. It has a network inside of it, and I can then write my code inside of this network. Now what you'll notice alongside the actual program of the StartStop Latch, we also have our local labels, this guy right here. It's also here. And these local labels are very similar to our local labels inside of our POU, like this, and our global labels inside of Global 1. The difference between our local labels here and our local labels of our POU is the type of class. If we go to our POU and we drop down the class here, you will see two options. You've got a var and you've got a var constant. A var is like an internal bit to the block. It can be used inside of that block and nowhere else in the program. And a var constant is an address that will remain the same value. If you look at our local labels for our function block, however, you are then given some extra classes. We have our var, which again is an internal address to the block, cannot be used anywhere else. We then have our var constant, which again is just a value that remains the same. And then we have our var input, our var output, and our var in and out. So what are these three guys right here? Well, the var input is a signal that can be used inside of our function block that is coming from the main program into the block. These can be used as contacts only with inside of that block. Nothing else, contacts only. These are read signals. var outputs again can be used inside of our function block, but they go out to the main program, and they can then be used inside of the main program to control whatever. Again, these can only be used as coils. These are write conditions only. And var in out, if you haven't guessed, these are a combination of them both. These can go into the block and out of the block, and they can also be read and written to from within inside of the block and the main program as well. So what I want to do first of all is I want to create the ladder to the StartStop Latch, just the ladder, and the ladder is going to remain exactly the same. I'm going to have a normally open contact, I'm then going to have a normally closed contact, I'm then going to place in my output coil our normally open contact latch, and then I'm going to join the bottom rung to the top rung here. And then it's going to ask us for addresses. Now what I could do is I could tie this to X0, X1, Y0, etc. The only problem with that is I could then only use that block once inside of the program, because that block is now using physical addressing. And if I use that block again, this output, which would be Y0, would be duplicated, and that would cause problems inside of my program. What I have to do is I have to create local labels for this. So if I look at this guy right here, this would be our X0 or our start condition. So what I'm going to do is I'm going to go to my local labels and I'm going to create a label name. I'm then going to call this start PB. I'm then going to tell it what type of class to be, and it's automatically selected it as a var. The problem is this start push button is going to be accessed from my main program. It's going to come in from the main program, let's just say M0, and when M0 turns on, I need the start push button to then turn on with inside of the function block. To do this, I need to tie this as a var input. Now what I can then do is I can then go to this normally open contact, and then I can type in here start PB, and there you go, you can see it right there. If I double click that, there's my start PB. The next address that I need to create is my stop PB. So again, stop PB, enter that. It's chosen as a var again, but similar to my start PB, I want this to be a var input, as again this is going to be controlled from the main program. So this is going to be my stop PB. There we go, enter that. Finally, what it's then asking me for is it's then asking me for our output coil. Now our output coil and the contact is going to be addressed to the same address. This is going to be our latching bit. If I go back to my local labels, let's just call this lamp. Again, I can't just select it as a var, but I can't just select it as an output, even though it's going to be used as an output coil, because it's also going to be used as a contact. Now, because it's going to be used as a contact and a coil, and it's going to be accessed from the main program, I need to select this as var in out. Select it as a var in out, and then what I want to do here is I then want to give it the data type bit. So each of these is going to be a bit inside of the program. It's just going to be on or off. Now I can then go to my output coil, tie this to lamp, go to my contact here, tie this to lamp, and there we go. That there is the program for my function block designed. And what I can do now is I can now save my work, and I'll just call this Chris function blocks. And then I can close down the StartStop program, close down my local labels, and then I can go back to my POU. Now what I'm going to do here is I'm going to leave this as it is, and I'm going to create a new block. So right click, new block after, and I'm just going to expand this a little bit. And what I'm going to do now is I'm going to drag and drop the StartStop Latch function block into network 2. So I'm going to just drag it over, drop it in, and it's going to ask me, just like it did with our timers, it's going to ask me for a name, a label for this block. This is very similar again to Siemens instance data blocks. When I add this name, StartStop Latch 1, to the program, like so, this block is then assigned that data block. And when the PLC executes the code from this function block, it's then going to store it inside of that data block here, the StartStop Latch data block. And what this will allow the PLC to do is it'll then allow the PLC to then go back to that data block, pull out the data that it recently executed on the previous scan, and then use it again on the next scan. So it allows the PLC to have some sort of memory for this block right here. Now you can see here it's asking me to address our start push button, our stop push button, and our lamp. Now all we want to do here is we just want to address it to the addresses that we would use inside of the program. So for my start push button, I'm going to tie this to M0. For my stop push button, I'm going to tie this to M1. For my lamp, I'm going to tie this to Y1 because we're already using Y0. And that there is my function block addressed. Next, all I need to do is just save my work, compile my work, rebuild all, select yes to that, and you'll see there 0 errors, 0 warnings, 0 check warnings. I can then close that down. Everything on the left hand side, which was red, is now black, which means it's being accepted, and that there is my program ready to go. But as I mentioned before, the benefit to using a function block is I can use this multiple times in my program. So what I'm going to do again is I want to drag and drop this StartStop Latch back into this network, and now it's going to ask me for another data block, and this one is going to be different to my first one, so it's going to be StartStop Latch 2. I'm just going to apply that, which then allows the PLC to store information from this program here into the data block. And then what I'm going to do is then tie up my start push button, stop push button, and my lamp for this one. So let's just say this one is M10, M11, and Y2. I can then create another one like that, give it another data block, apply that, close that, keep that in line, and then address this start PB to M20, M21, Y3. And you can see just from me doing this how easy it is for me to just add a block to the program, address the block, and then just use it as many times as I want inside of the program to then complete the same task without me having to redesign the program over and over again. So what I'm going to do now is I'm going to save this once again, and I'm going to compile this, rebuild all, and then select yes. There we go, everything's fully checked out there, okay. I can then close that, and then what I want to do is just set up the communications for this program. Go to connection 1, it's already selected COM5, so that's great. I'll just do a connection test. Successful. Say okay to that, say okay to that, and then write to PLC. Select the main program, and then select execute, and then select yes to stop the PLC, and now it's going to begin downloading. Okay, that's that downloaded. Next, we're just going to say yes, switch that back to remote run, close this down, and then we're going to go live on the PLC. Remember, to go live, we can just start monitoring all windows. Select yes to that, and here we go, we're live. So if I right click M0 and I just select modify value, and I'm just going to turn M0 on, what we should see is Y1 turn on, Y2 remain off, and Y3 remain off, because these two blocks aren't being executed. It's only this block here. So if I just select on, there we go, I can then turn that off, and the lamp remains on, which is Y1. If I want to stop this block right here, I just select the stop push button, turn it on, it then turns the lamp off, switch it back off again, and that's that block working. If I then select M10, turn this one on, this then turns on the second lamp, turn it back off again. I can then go to M20, turn that one on, Y3 then turns on, turn that one off. I can then reset Y3 by pressing M21 and turning that off. I can then reset Y2 by selecting M11, turning that on, and then turning that off. So what I've got is I've got a very simple program that's just been designed once inside of a function block, and then that's used multiple times inside of my main program. Each block is then assigned a different address, and then each block works independently from each other because it's all storing its information in its own individual data block. There's StartStop Latch 1, StartStop Latch 2, StartStop Latch 3, etc. And you can just see here how easy it is to actually design a program using a function block multiple times. Saves us a hell of a lot of time, when before in the past you would just have to rewrite the program multiple times. As I mentioned, it's not too difficult when you've just got one network, which is just 3 contacts in a coil. But if you've got a program, let's say that's controlling a conveyor, and that program is 10 networks long, and on the shop floor you've got 10 conveyors. Instead of you having to rewrite those 10 networks 10 more times, giving you 100 networks in total, all you do is you take those 10 networks to control that one conveyor, place it inside of a function block, address it all up inside of the function block using its local labels, and then use that function block 10 times in the program addressed to the individual addresses of each conveyor. And that's it, job's done. Now what's great about Mitsubishi is I can then just double click any function block I want, and it will show me the current state of that function block only using the data block alongside it. So at the moment everything's off, but if I go to my main program and I just turn on the start PB, we can then go to the block for that, and there you can actually see the start PB is on and the lamp is on. If I open up StartStop Latch 1, that block remains as it was previously, because this block is only showing you the information for the very first StartStop Latch. The only downside is you can't view multiple blocks at the same time. So if you look here, it's only showing you now the StartStop Latch for the very first block. And if I just hover over the actual tab, you can see there StartStop Latch POU1.StartStop Latch _1. if I go back to my main program and open up StartStop Latch 2, that then replaces that previous block with this new block here. You can only monitor one at a time, but if I hover over it, I can then see StartStop Latch 2. If I go back and I double click StartStop Latch 3, I can then hover over it, and there's my StartStop Latch 3. So I can actually monitor each individual block within inside of the program just by double clicking the block, which is a nice little thing that Mitsubishi has provided to GxWorks too. Makes monitoring programs a lot easier, especially if I develop a fault with, let's say, Conveyor 2. I would just go to Conveyor 2, double click its block, and then I can monitor the program within inside of that block. It makes fault finding a lot easier when it comes to troubleshooting within a certain block. So what I want to do now is just select the start stop, turn that on, select my stop push button, turn that off, select the stop push button, turn that off, and then it's back to normal. Close that down, and that there is my program with function blocks designed. And that's it. That there is a basic introduction to function blocks within inside of GxWorks 2. As I mentioned, it is just a very basic program. I didn't want to go too in depth with having several networks designed inside of there. I just wanted to show you quickly how we can actually design function blocks inside of GxWorks 2 and then use them inside of the main program. Because if you're working on the shop floor now in today's industry and you open up a ladder program like this, I would be very shocked to find out if there are no function blocks being used. And that's all I wanted this video to be, just a brief introduction to function blocks within inside of GxWorks 2, how to create them, how to assign local tags, how to assign a data block to them inside of the main program, and then how to monitor them inside of that program. Once again, I hope you've enjoyed this short little free training video on Mitsubishi PLCs, and I look forward to seeing you again next time. Thanks a lot.